In this lesson, we're going to be working on synthetic substitution. Synthetic substitution is another way to evaluate a polynomial. We can use it instead of substituting x into a function. So here are the steps. First, we place the x value on the outside. We list all the coefficients of the polynomial in descending order, meaning largest to smallest, when it is talking about the exponents. And then we solve. We bring down the leading coefficient, we multiply times the number out front, we add to the next, and so forth. So I think the easiest way is for us to try one. So what we're going to do is we make sure that our polynomial is in standard form, and it is. So we put our 4 out front. I like to do it with a right angle symbol. We bring our coefficients, so we have a 5, a 1, a -4, and a 1. And if you're missing any of the variables, in other words, if there's an x squared missing or if there was an x missing, you would put a 0 in as a placeholder for that coefficient. So first we bring down our leading coefficient, which is 5. We multiply 4 times 5 to get 20. Then we add the two together. Then we take 4 times 21, which gives us 82, and we 84. We multiply the two together, got 84, then we add. Then we multiply 4 times 80, which is 320. Then we add, and our final answer will be 321, and you would get the exact same thing if you were to substitute 4 into the polynomial and solve that way. Okay, let's try another one. X squared plus 3x plus 4. This is in standard form, so we're going to put our 2 out front. We have a 1 in front of our x to the 6th. We do not have an x to the 5th. We do not have an x to the 4th. We do not have an x cubed. We do not have an x squared. But we do have an x, which would be a coefficient of 3, and then we put our constant term. So we're going to bring down our leading coefficient, which is 1, and we multiply. Then we add. We multiply 2 times 2 to get 4, and we add. We multiply 2 times 4 to get 8, and we add. We multiply 2 times 8 to get 16, and we add. We multiply 2 times 16 to get 32, and we add. We multiply 2 times 35 to get 70, and we add, and we would get the exact same answer of 74 if we were to use our calculator and plug that number in for x. Next, synthetic substitution. We have 3x to the 5th minus x to the 4th minus 5x plus 10. It is in standard form, so we're going to put our -1 on the outside. 3x to the 5th, a -1x to the 4th. There is no x cubed, there is no x squared. We have a -5 in front of our x, and our final constant value is 10. We're going to bring down the 3, which is our leading coefficient, then we're going to multiply. We're going to add these together, and then we're going to multiply. We're going to add those together, and then we're going to multiply. We're going to add them together, and then we're going to multiply. We're going to add them together, then we're going to multiply. And when we add them together at the end, this is our answer that we would have gotten if we would have plugged that into our calculator. Let's try it with a 2. So remember, 3 is our leading coefficient. -1 is our coefficient in front of the x to the 4th, but there is no x cubed, there is no x squared. So we have a -5 in front of the x, and 10 is our constant term. So we'll bring down our 3, multiply, add the 2 together, 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 multiply, add the 2 together. Our final answer of substituting in a 2 into our polynomial would be 80, and we would get the exact same answer if we were to use our calculator to plug it in. This is synthetic substitution.